4.3, what is the best design for a solar water heater? And I have included under the extensions an activity that you can do using a pop bottle to build your own solar water heater. So our question today is really, how can we catch the energy we receive from the sun's rays and put it to work for us? One relatively easy way is to let sunlight fall on water to heat it. The pioneers traveling across the West in the 1800s had already figured out that by storing water in black pots on a sunny day, they would have hot water to use at their evening campsite. Today, Rooftop solar water heaters provide a clean, safe alternative to more costly gas and electric water heaters. Solar water heaters are often paired with conventional water heaters, which are a hedge against times when the weather is cloudy or extremely cold. Many parts of the United States receive ample solar energy all winter long to heat water and warm a house. Solar water heaters have to meet several challenges. First, the sun's energy must be captured. Sunlight is waves of electromagnetic radiation. Light waves radiate from the sun in all directions. The electromagnet spectrum is made of a number of different wavelengths. We are most familiar with the narrow range of wavelengths known as visible light, but we also know about visible light's closest neighbors in the spectrum: ultraviolet, so your sunburn, and infrared, warm rocks after sunset. We see light from the sun as white light. White light is a lot of different wavelengths of light traveling together. White light is a lot of different wavelengths of light traveling together. By using refractive devices called prisms, so I'm trying to think, I don't think I have anything in the classroom, but alright, so I'm looking at my door right now, and the way it's cut, the glass is cut into several different prisms, so that means when the light comes through it, it shows a rainbow. Alright, maybe some of you have something like that at home. Alright, and that can separate the white light into its different wavelengths. The different wavelengths we perceive as different colors. The rainbow is a classic display of all the colors of light that fall into the visible range. Just beyond violet is invisible ultraviolet, those high energy wavelengths that are potentially dangerous to life, and down beyond red is infrared, which is often referred to as simply as heat. In fact, when you go to a hardware store and purchase a heat lamp to provide relief for an aching shoulder, you are buying a lamp that produces lots of light in this invisible infrared range. When sunlight falls on an object, several things can happen. If light falls on a sugar cube, a piece of chalk, or a skirt of bleached muslin, all of the light simply bounces off or reflects, so these things look white. But if that same white light falls on a pumpkin, a green bean, and a strawberry, they look orange, green, and red respectively. Why? Because the fruits have pigments in their skin. That absorb some colors of light and reflect others. So, for example, the pumpkin absorbs all but the orange light, so orange reflects from the pumpkin skin into our eyes, and we interpret that particular wavelength as orange. And so it goes with all materials. The colors you see are the reflected wavelengths of light. Black is another case. Black is the absence of all colors of light. So when sunlight falls on a crow, a lump of coal, or a licorice whip, most visible light is absorbed. When light is absorbed, the material doing the absorbing responds in some way. The most common response to absorbed light is to increased kinetic energy of the particles in the material. Motion equals heat, so materials that absorb light get hotter. Back to the solar water heater. Dark surfaces absorb energy from sun, and white surfaces reflect energy. Black material often serves as a collector in solar water heaters. Black material often serves as a collector. A solar collector is any object or material placed in the sun to absorb solar energy for subsequent transfer to air or water. The size of the collector is important. The larger the surface area, the greater the amount of energy it can capture. The amount of solar energy exposure is important. When you want to heat a given amount of water, more energy transfer means the water will heat up faster. After capture, the energy must be retained. How do we retain the energy? If you place a transparent cover over a pan of water, all visible light and some infrared radiation will pass right through the cover. A dark collector in the pan absorbs the light and heats it up. A hot collector radiates energy in the form of heat, or infrared. The energy transfers heat to the water. Because the clear cover is only slightly transparent to the infrared radiation, heat stays inside the covered solar water heater, increasing the efficiency of the system. The water gets hotter and hotter. Greenhouses, parked cars, and living rooms heat up because of this energy transfer. You park your car in the sun, roll up the windows, and head for the mall. While you are shopping, sunlight shines through the windows. Some infrared light and all the visible light passes through the glass and strikes the dash and upholstery, where most of it is absorbed. This material gets hot and begins to radiate infrared light, heating the air in the process. The infrared light cannot pass through the glass as efficiently as visible light, so heat builds up in the car. And so that is why, on a hot summer's day, or even slightly warm, if you leave your car out in the sun, and then you get back in your car later and it's suddenly warmer, that is why. And so what you guys are going to be doing is, how do you build a solar water heater that's efficient? And I've given you guys a plan for that is an extension. And just the best of luck to you guys.